Good morning or afternoon. Today you're going to be working through a Desmos activity during this video. So the first thing that you need to do is make sure that you have a piece of paper and a pencil or your notebook for notes. You need to open the Desmos activity linked on today's assignment that you'll use in just one moment. Pause this video. Make sure you have your supplies that you need. If we think of these, can you figure out which of these relations doesn't represent a function? What do you think? 1, 2, or 3? 1 has the ordered pairs 2, 3, 4, 5, 6, 7, and 8, 9. All of these, the x's don't repeat, so this one is a function. For the relation number 2, we have the ordered pairs 3, 4, 5, 4, 6, 7, 8, 3, and 2, 4. If I look at my x values, none of them repeat, so this is a function. So let's look at the last relation, 2, 7, 5, 6, 6, 4, and 9, 10. The x's don't repeat, so this one's a function. A little bit of a trick question there, because all of them represent a function. Okay, this is our objective for today. I will be able to find the rate of change slope from an equation, graph, table, and ordered pairs. We have basically 4 different sets. We have 4 different chunks where we focus the first chunk on equations, the second on graph, the third on the table, and the fourth on the ordered pairs. So let's start with equations. In your notes, you need to title your notes page Finding Slope, but then do a subheading called Slope-Intercept Form. Slope-intercept form is the name of an equation. It's a very special equation because if we go back to our standard, you'll notice that it is written in the standard. So in the standard, that second sentence says recognize in y equals mx plus b that m is the slope or rate of change and b is the y-intercept of the graph. So our slope-intercept form is the equation y equals mx plus b. Write this in your notes. Where m represents the rate of change or slope, we can use both of these words, and b represents the initial value or the y-intercept. Write both of those words. This equation is super important. As long as you get the hang of what this equation represents, finding slope from this equation is going to be super easy. I want you to pay special attention that in the equation y equals mx plus b, the m has a square around it. And that square only includes the m. It does not include the x. That's very important. So let's look at an example. Example A says slope from an equation. This equation is y equals 4x minus 7. So in order to identify the slope, I'm writing down my slope-intercept form, y equals mx plus b. And I'm looking at what is in the place of m on this very similar equation in our example. And I notice that a 4 is in front of the x. So my slope, m, equals 4. It does not include the x. It's the coefficient of the x term. I'm only looking at the number. That's it. That's how I find my slope. Let's do another one. Example B is y equals negative 1/3 x plus 10. Can you figure out what the slope is? If my slope-intercept is y equals mx plus b, what is in the place of the m in my original problem? My slope is equal to negative 1/3. Again, I'm not including the x, but I am including that negative. Very important. Let's do one more example. Example C is y equals 12 minus 2x. So if I write down my slope-intercept form, y equals mx plus b, I notice that my example, y equals 12x minus 2x, is kind of messed around. I'm looking at the number in front of x for my slope. So the number in front of x is negative 2. I could rewrite this equation as y equals negative 2x plus 12. So I have to include that minus sign in front of that 2. Notice again, I do not have the x. So right now, what I want you to do is I want you to go to your Desmos activity and I want you to try problems 1 through 4. You have approximately 3 minutes to complete this. Pause the video, complete it, and then come back after 3 to 4 minutes. We'll just put a timer in. That's 3 minutes. So you should have finished not finished, but worked on it. And you probably are stuck at this extension of y equals 5. What's the slope here? So let's think about our slope equation, y equals mx plus b. And I'm thinking about my equation of y equals 5. Now, whatever doesn't have the variable is going to be in place of my b. So now I have to think about, if I put my x there, what number am I going to put instead of m so that the x cancels out? What number do I multiply by x to get 0, to get nothing? If you said 0, that your slope in this case is 0, you're correct. Let's go over some others. For problem 1, you should have put that the slope is -3. For problem 2, the slope is just that +4. For number 3, the slope is in front of that x as 2/3. Okay, next you will see a table. So let's go ahead and talk about tables. The rate of change from a table, how do we find that? So you need to be writing notes again. The rate of change from a table, we use the slope fraction, slope ratio, rate of change ratio of change in y over change in x. Wednesday in Zoom, we talked about using the triangle instead of change in, and that is also a way that you can do it. Just make sure that you know that the triangle stands for change in. And this is our slope ratio. So let's use it. I have a table here, for example D. My table, my x values are 3, 4, and 5, and my y values are 17, 22, and 27. I have a very specific way that I want to do this, and I want you to copy exactly what I write down. The first thing I'm writing down is I need to be able to find that my slope I get by putting numbers into this ratio of change of y over change of x. So I have to find my change in y. So I'm going to go over to the right side of the table. I'm looking at my first value of 17 for y, and I'm going to 22. What am I doing there? I'm adding 5. So 5 is going to go on top of my slope ratio, my rate of change. Then I'm going to go to my x's, and I do 3 to 4, I'm adding 1. So the bottom number is going to be 1. But the question asks, is this function linear? So we need to make sure that all points of it are linear. So we go from 22 to 27, I'm adding 5, and from 4 to 5, I'm adding 1. So my next slope ratio of change in y over change in x is also 5 and 1. Since they are the same, it's constant, it is going to be linear. So my slope for my linear line is m is equal to 5. Let's try another example. Example E. Example E has the x values of 1, 5, and 12, and the y values of 6, 12, and 18. Again, I'm going to have my slope ratio of m equals change over y over change in x. So if I look at my y values, if I go from 6 to 12, I'm adding 6 to 6 to get to 12. And from 1 to 5 on my x's, I'm adding 4. So 1 plus 4 gives me 5. Now I can put those changes, so I'm putting my red numbers in my slope ratio. So 6 over 4. And I can simplify that down to 3 over 2. Okay, let's do the next set. I have my change in y over my change in x. I'm looking from 12 to 18. I'm adding 6 to 12 to get to 18. Great. What number do I add to 5 to get to 12? I'm adding 7. So my top number in my ratio is 6 and my bottom number is 7. Does 7/6 equal 3 over 2? No, it doesn't. They're not equivalent. So this function is a non-linear. And all that means is that I might have a point 1, 6, and the line to get to 5, 12 has one slope, and then the line to get to 12, 18 has another slope that looks different. It's just going to be a little steeper or less steep, and so on. Okay, let's try another example. Example F. My x values are 0, -10, and -20, and my y values are 24, 12, and 0. So I'm using my slope ratio of change in x over change in y. So if I'm looking from 24 to 12, I'm actually going down 12 places. And from 0 to -10, I'm going down 10 places. So my slope ratio, my -12 is going to go on top, and my -10 is going to go on the bottom. Because my -12 is referring to the y's, and the y is on top. Actually, I wrote my slope ratio wrong there. I should see change of y over change in x. So my y goes on top. All right, now I have -12 over -10. I can simplify that down to -6 over 5, -5. And then I can use Mr. Multiple Division. And I say a negative divided by a negative, that gives me a positive 6/5. Let's see if the ratio remained constant. So 12 to 0, I'm subtracting 12. And -10 to -20, I'm subtracting 10. So my ratio is still -12 over -10, which simplifies down to 6 over 5. So my slope for this table is m equals 6/5. I want to keep it in fraction form because it's a ratio. All right, let's go back to our Desmos activity, and we're going to do problems 5 through 8. This time, we are actually going to have 5 minutes for you to do this. So let's put on a timer for 5 minutes. Go ahead and begin your Desmos while you wait. right, so you should have done problems 5 through 6. So the slope for the first problem, number 5, is actually going to be 10 over 2, which reduces down to 5 over 1, which is equal to 5. So you should have had, you can write it as your reduced fractions just like I have, but you need to have that 5 over 1 or 5 in there at some place. If you left it as 10 over 2, you need to make sure that you're simplifying it. If you put it as 2 over 10, it means that you flip the ratio and you put x, the change in x over the change in y instead of the change of y over x. For problem 6, our answer is positive 7 because we have our change in y's is negative 7 over our change in x, which was negative 1. And so that all cancels out and you get positive 7. For number 7, you should have identified that it is a nonlinear function because the rate of changes are not equal. And then an extension, I can look at that here. So let's go on into the next section, which is how to find the slope from two ordered pairs. And I think what is the easiest way to do, and in this case, example G, we have an ordered pair of negative 3 and 7, and the ordered pair of 7 and 12. I think the easiest way to do this is to put it into a table. So on my left, I'm going to have my x values, and on my right, I'm going to have my y values. I need to make sure I put my x's, which are the first coordinate, in my x column, and that I put my y values into the second column. So 7 and 12. Notice here how my coordinate pairs of negative 3, 7 are on the same level. So you want to make sure your coordinate pairs are across from each other horizontally, not vertically. So now that we've put them into a table, we can do just like we did the last time, where we're finding our change in y over our change in x. So if I go from 7 to 12, I'm adding 5. And if I go from 3 to 7, negative 3 to 7, my apologies, I like when it gets to negatives, for it to be less confusing, I like to draw a number line out, and I actually count that way. So negative 3, and if you do that, you'll get positive 10. So my slope for between these 2 points is actually going to be 5 over 10. But I have to simplify that. They both can be divided by 5, and I get 1/2. So my slope for these two ordered pairs, is m is equal to 1/2. Let's try another example. I have the ordered pairs on example H is 15 and 12, and 10 and negative 2. So I have my table of x and y, and I'm putting it into the table. I have 15 on my x column and 12 on my y, and 10 on my x and negative 2 on my y. If I look for the change in y over the change in x, my change in y, I'm going from 12 to negative 2. That means I'm going downwards on my number line. I'm going down 14 places. And then on my x's, I'm going from 15 to 10. I'm going down 5 places. So if I put that into my slope ratio, I have negative 14 over negative 5, which simplifies down to 14/5, because my negatives cancel out. If I have a negative divided by a negative, it gives me a positive according to Mr. Multiple Vision. All right. Go ahead and try problems 9 through 11. You'll have 5 minutes to do 9 through 11. On the first one, you'll notice that it says use the table if needed. So put your x values and your y values. And we're going to put the timer on for 5 minutes again. right, that was 5 minutes. So let's go over our answers. For problem number 9, you should have gotten a slope of 1. And that's because if you had put the numbers into the table, you would have gotten a difference on your change of y's of 8 and on your change of x's of 8, which would equal 1. For question number 10, you have our ordered pair here of 22 and 7 and 13 and 22. This one has been really tricky for most people. From 7 to 22, what are we doing? We are going up 15. From 22 to 13, we're going down 9. So our slope is 15 over negative 9, but we need to simplify that down. 15 and 9 have 3 in common, so that simplifies down to negative 5/3. I had a lot of people in my last class put some variation of 15 over 9, but they missed the negatives, or they didn't simplify, or they flipped it. So our final answer is negative 5/3. Negative 5/3. Okay, let's go on to the last chunk of today's lesson, which is finding slope from a graph. And right here, it's really important that you take good notes at the beginning, because when you have the graph part, it's going to be a little bit harder for you to graph. So, the notes that I want you to have is, first we talk about, when we talk about slope, we talk about the steepness and the direction. So the first thing I want you to write is the direction. So when we talk about direction, we either talk about the line being a positive line or a negative line. Then we talk about steepness. And that's where we talk about our rise over our run. Rise over run. This is our slope ratio, which is the same thing of change of y over change of x. So, if our slope is positive, it means going from left to right. Our slope is going upwards. It's going upwards. If it's negative, from left to right, like if you're reading in English, it's going downwards. Then we have to talk about our rise, which is going vertically up like the sun, and our run, which is going side to side like a crab. And pardon my little diagram of a crab. So let's put this into practice. Our first example, which is example J, has a line. If we look at the direction of our line, it is going downwards. So our slope is going to be negative. Then we need to look at our rise over our run. So what do I have to do is I have to find 2 perfect points. In this case, our perfect points are already highlighted for us. So what I'm going to do, and this is a strategy that you might want to do, is to draw a triangle between them that has a right angle. So the corner is a right angle. Now, if I think about my rise, I rise up and down like the sun. So the sun rises. and I'm going to count my boxes. So I have 1 box, 2 box, 3 box, 4, 5, 6, 7 boxes on my rise. And then on my run, like a crab that goes side to side, I'm going 1, 2, 3, 4 boxes. So my slope on the ratio is going to have 7 on the top and 4 on the bottom. Now notice how here I wrote my negative as words. Now I have to put that into a sign. So I have a negative 7/4 is my slope for this graph. Something that's really important that you want to try to avoid is counting the lines instead of the humps. Because if you count the lines, you're going to count an additional point. So here if I count the lines, I actually end up with 8 instead of 7. So don't count the lines, only count the humps between the lines, the boxes. All right, let's try another one. Okay, here we have a line. Is this positive or negative? In this case, it's going upwards. So it's a positive slope. And now I need to find my slope ratio of my change in y over my change in x. So I'm finding 2 perfect points. On this graph, I don't have those big points, so I need to find perfect point, which is where the line intersects the graph behind it, vertically and horizontally. So if I look here, I have a perfect point at the bottom where it crosses, and a perfect point kind of at right there. So what are those coordinate points that are perfect points? I have -2 and -4, and then I also have -1 and +1 are my coordinate points associated with that. Oh wait, now I'm going to connect my points by drawing a triangle. It doesn't matter if you draw a triangle to the left or to the right, as long as you have a 90-degree angle at the bottom. And now I want to talk about my rise, like the sun. So I'm counting my boxes going up and down. I have 1, 2, 3, 4, 5 boxes going up and down. So I'm putting that on the top of my ratio. And then I want to talk about run, like a crab going side to side. And I have 1 box there. So my bottom number is going to be 1. So my answer, since it's positive, I don't have to put a special signal, is going to be 5. My slope is equal to 5. Let's try another one. Right here, we also have another positive slope. Here I want to notice that you have actually 3 perfect points. We have a perfect point where it intersects the graph at 1, 4, at the origin, which is 0, 0, and at -1, 4, -4. Okay, so you can draw a triangle between any 2 points. Ideally, you want to have it between the closest 2 points, but I'm going to show you what happens if, say, you forget and you didn't see the origin. What happens if you make a triangle between 2 points that are further away? Okay, so we first want to start off with our rise, because that refers to our change of x. Sorry, my change of y, like the sun. Counting my boxes, 1, 2, 3, 4, 5, 6, 7, 8, going up 8. And then from side to side, like a crab, I'm going over 2. So my slope is positive 8 over 2, which simplifies down to 4 over 1. So my slope is positive 4. One more example. Example M. Example M is a line that, if you're looking at it from left to right, is going downwards. So my slope is going to be a negative number. And then I have a number of perfect points here. And it's basically at every point on that line. So I have a perfect point at negative 4, positive 1, at negative 3, 0, at negative 2, negative 1, at negative 1, negative 2, etc. So I'm just going to look and see how there's one box rising and one box running. That means that there is a slope of 1 over 1, but it's a negative, so my slope is negative 1. All right, let's go ahead and try problems 12 through 15 on Desmos. We're going to have 5 minutes to get these done, so let's reset and start on your Desmos. Questions 12 through 15. Okay, so let's go over the questions. Question 12, our rate of change for question 12 is 1 over 2. If you pick any 2 points, it's going to be a rise of 1 over a run of 2. For question 13, it's a negative, and again, negative 1. For question 14, we find our 2 perfect points. In this case, I have a perfect point at negative 1, 1, and a perfect point at 4, negative 1. And my slope is going to be 2 over 5, but it's a negative, so my slope is negative 2/5. And for question 15, we have a positive slope, and our slope is going to be 1 over, 2 over 1, which gives me a slope of 2. Okay, so for the remainder of class, you have slides 16 through 26 as your practice of what we learned today. At the end, number 23, 24, 25, and 26 are some extension problems. You guys are all honors classes, so I expect that you would get here and to try these. I'm not expecting you guys to get them correct, but you should try them. Now, when you are done with this, then you are going to go and ask the guest teacher for the extension activity. The extension activity is also going to be linked to your Canvas page. So, for example, this is not what your Canvas page it's going to look like 100%, but at the very end it has this extension activity where you have to graph it from a slope-intercept form. Okay? So I realize that this video was long, but hopefully you had time to work while this video was going. I will see you guys on Monday.